In this video, I'd like to show you another feature of Desmos that we can use in our classroom. Typically, when we go to Desmos, we click on Math Tools, and a lot of you go to Graphing Calculator or Scientific Calculator. But now I want to explore this one down here. This is what we usually get with our graphing calculator, and what I did is I graphed a system of equations, these top two, the red one and the blue one, and I saw they crossed at 5, 3. But there is another option to use matrices. Now, when you go to the matrix calculator, now you have a calculator that operates with things as matrices. So if I create a new matrix and I put in my coefficient matrix, just like I had on that previous window, and I make another new matrix, but I only want this one to have one column, so I edit down here and I put in the two answers or the constants. Now I have the matrices into this calculator and I can do calculations. And we've learned that in order to solve this system using matrices, I take the inverse of A, so there's the inverse already, and I want to multiply this times B. Now what comes up is a 2 by 1, and you'll notice that 5 and 3 are my X and Y from my graphing. So I solved this system by making two matrices and then doing A inverse times B. I want to show you another example. First, I'll show you on the regular graphing calculator. So I'm going to turn off the red and blue one. I'm going to turn on the green and purple one. Here's an example where these two lines don't cross, so they don't have a solution. So if I put these coefficients, 4, -6, -10, and 15 into a matrix, and put the 9 and the 8 into a matrix, let's see what happens with the matrices. So I'm going to put in 4 and -6. I'm going to put in -10. I'm going to put in 15. And for the constants, I'm going to put in the 9 and the 8. Now, we already have an issue here. We have this little orange triangle, and if I kind of hover over it, it says singular matrices do not have an inverse. I'm going to even make it more simple here. I'm going to take off the times B. It's the inverse that has the issue because there is no inverse. So let me show you why there's no inverse. If I do DET, that stands for determinant of A, it's 0. And we've learned that matrices that have a determinant of 0 do not have an inverse. So when I tried to do the inverse of A and multiply it times B, I got this singular matrix error because, as the graph shows me, these two don't cross. Now, the best part about having these matrices, this matrix calculator, is what happens if I have a bigger one. What if I have 3 equations, 3 unknowns? So let's put these in and see if this still works. There's matrix A, and now I'm going to make matrix B, and it's going to have 3 rows, but just that one column. Remember, that's the constants. Sometimes I refer to them as the answers. Now when I do A inverse times B, there's my 3 answers. There's my X and my Y and my Z. So doing 3 equations, 3 unknowns got really, really easy if I know how to write the coefficient matrix, the constant matrix, and I can do this particular calculation. In this video, I'm going to look at one of the features of the Desmos calculator. I opened up the graphing calculator and I put a couple of equations in here. This is actually a system of equations, so I'm interested in this point down here where they cross at 7, -2. What I'm going to do now is I'm going to open up the matrix calculator and I'm going to look at this exact same example as a matrix. But I'm going to do something a little differently with this one. Instead of making two separate matrices, I'm going to put them together. So I'm going to put in the coefficients and the answers all in one matrix. So if you want to think of this as a 2 by 2 matrix here, 1, 4, 2, and 5 are my coefficients. 1 and -4 are my constants or my answers. So I have that entered now. And right down here, there's this rref. That stands for row reduced echelon form. It's not important that you know what that stands for. It's important to know how to use this. So if I go rref of matrix A, what it's going to do is where the coefficients were, there are now 1, 0, 0, 1. That's the identity matrix. And over here, where the constants were, we now have 7 and -2. So essentially, this first row says x equals 7. The second row says y equals -2. If you remember, when I graphed these, they cross at 7, -2. So by putting it in as one bigger matrix, a 2 by 3, and doing rref, I got my two answers in one step, not having to do multiple steps. And this would work for a 3 equation, 3 variables. I would just have 3 rows, 4 columns, instead of having that square 3 by 3. Now, I want to show you something interesting with this. I put another example in here. My green and my purple lines don't cross. So when I do something with the matrices, I should run into an issue. So I'm going to put these in. So we've got 4, -6, which are the coefficients, 9, which is the constant, -10 and 15, the coefficients, 8, which is the constant. So now when I try to do rref, you'll notice I don't get that singular matrix, that identity matrix here, that 1, 0, 0, 1. It didn't work. I got 0x plus 0y equals 1, which doesn't make sense. Or 1x plus -1.5y equals 0, which doesn't make sense. I didn't get answers. And the reason I didn't get any answers is these lines don't cross. So if I don't get that identity matrix right here, it's not going to work doing it this way. So let's go into this matrix and let's make it bigger. Let's go 3 rows, 4 columns. Let's do a 3 by 3. And I left the rref, the row reduced echelon form, up here. And notice I have 1s down the main diagonals, 0s everywhere else. And over here I have my answers, 1, half, and 3. 1 is my x, a half is my y, and 3 is my z.